Hello everyone, I am Mohammad Rumesha Firdos from 2CSEC, bearing roll number 21BQ1A05E7. Now I am going to discuss about basic operational concepts of a computer organization. To perform a given task, an appropriate program consisting of a list of instructions is stored in the memory. Individual instructions are brought from the memory into the processor which executes the specified operations. Data to be stored are also stored in the memory. So for example, if we take the command add loca and or not, this instruction adds the operand at memory location loca to operand in register or not, places the sum into the register. This instruction requires the performance of several steps. Number one, first, the instruction is fetched from the memory into the processor. The operand at loca is fetched and added to the contents of or not. Finally, the resulting sum is stored in the register or not. The preceding add instruction combines a memory access operation with an ALU operation. In some other type of computer, these two types of operations are performed by separate instructions for performance reasoning. So for other example, load loca R1, add R1 and R0. Transfers between the memory and the processor are started by sending the address of the memory location to be accessed to the memory unit and issuing the appropriate control signals. The data are then transferred to or from the memory. Let's look at the diagrammatic representation of basic operations of a computer. The MAR, which is known as Memory Address Register, sends the address to the memory. The data in that address from the memory is then sent to the Memory Data Register, which is known as MDR. The data from memory, if it is data, then it is sent to program counter. If the data from the memory is address, it is then sent to ALU and the operations from perform like arithmetic and logic units, and then it is sent to registers. So the figure shows how memory and the processor can be connected. In addition to the ALU and control circuitry, the processor contains a number of registers used for several different purposes. Number one is instruction register known as IR, holds the instructions that is currently being executed. Its output is available for the control circuits which generates the timing signal that control the various processing elements in one execution of instruction. Program counter PC. This is another specialized register that keeps track of execution of a program. It contains the address of the next instruction to be fetched and executed in the IR and PC. There are n general purpose registers are not. The other two registers which facilitate communication with the memory are MAR, Memory Address Register, and MDR, Memory Data Register. It holds a memory address register holds the address of the location to be accessed, and memory data register contains the data to be written into or read out of the address location. Operating steps are programs reside in the memory and usually get these through the input unit. Execution of the program starts when the PC is set to a point at the first instruction of the program. Contents of PC are transferred to MAR and a read control signal is sent to the memory. After the time required to access the memory elapses, the address word is read out of the memory and loaded into the MDR. Now contents of MD are transferred to the IR and the instruction is ready to be decoded and executed. If the instruction involves an operation by the ALU, it is necessary to obtain the required operands. An operand in the memory is fetched by sending its address to MAR and initiating a write cycle. When the operand has been read from the memory to the MDR, it is transferred from MDR to the ALU. After one or two such repeated cycles, the ALU can perform the desired operation. If the result of this operation is to be stored in the memory, the result is sent to MDR. Address of the location where the result is stored is sent to MAR and a write cycle is initiated. The contents of PC are incremented so that the PC points to the instruction that is to be executed. Devices require urgent servicing. To do this, one device raises an interrupt signal. An interrupt is a request signal from input and output device for service by the processor. Processor provides the requested service by executing an appropriate interrupt service routine. The diversion may change the internal storage of the processor. Its state must be saved in the memory location before interruption. When the interrupt routine service is completed, the state of the processor is restored so that the interrupted program may continue. Thank you.